All right, guys, let's talk about length of curves. This one really shouldn't take us too long. I know I've said that before, but I promise the reason this won't take us very long is because when you look at the integral, so you read in the book, right, that the length of a curve, or the length of a graph between x equals a and x equals b, if we have a function in terms of x, the independent variable, and y, the dependent variable, is the square root of 1 plus the derivative squared, right? The square, yeah, 1 plus the derivative squared. And they get that from, taking a curve and approximating it with little chunks, pretend that those are straight lines. And then we saw that that's really kind of just like the differential, and they went through that whole process of explaining it. So I'm just going to do 2 quick examples for you of this. The reason I'm not going to do a lot is because this is a very difficult integral to evaluate unless you have a very specific function, because the square root of 1 plus a function squared can be difficult to integrate with the techniques we have right now. Later on, we'll figure out a way to do it more easily, but for right now, this is all we got. So in this case, let's look at this. This is kind of a funny looking function I have right here. Y equals 4 square root of 2 divided by 3 times x to the 3 halves minus 1. We'll look at the graph of that here in a moment, but let's just do the calculus with this. I don't actually have to have the graph to evaluate its integral. So what do I know I need? I know I need the derivative, and then I'm going to square it. So a lot of times I'll just do some side work here. And we could also write the integrand here as 1 plus, right, dy dx, because that's another way to write the first derivative. Sorry, if I'm going to put equals, they better be equal. And if you put equals, they best be equals. So I got to put the equals, put all of it. So let's find what dy dx is, and then we'll look at squaring it. I'm not going to try and do this all at once in the same integrand, because it just gets a little bit messy, right? So I'm going to do a couple steps here. So let's look at what I have. I'm just going to rewrite the 4 root 2 over 3. Something's going to happen with that. And then bring the 3 halves down, take 1 away from 3 halves, I get 1 half, right? And then the derivative of 1 is 0. So there's a reason that this happened this way. So my 3's are going to cancel. 2 goes into 4 2 times, right? And it looks like we get the derivative to be 2 root 2 x to the 1 half. And this is going to work out pretty nicely. So what is my length? We only want x between 0 and 1. So I'm going to go from 0 to 1. Square root of 1 plus the derivative, which in this case is 2 root 2 x to the 1 half. Sorry, I don't know why my program's kind of making those weird values there. Dx. And now all we have to do is simplify and take the antiderivative. That sounds so simple, but that's probably not going to be, well, this one's not going to be too bad. So I get 1, and now let's talk about, because I understand that algebra can be hard sometimes, and remembering some of the rules of algebra is even harder than the calculus itself. So when I square something, I want you to remember, I know you already know this, but when I have multiplication, I do square each term. If this was addition, people, you absolutely do not square each term. You do not distribute over addition, right? You would have to FOIL this out. So don't do that in that case. That's like, I swear, mathematicians' pet peeve, or at least math teachers' pet peeve. So I'm going to square each one of these. I know I'm doing every single step. I wouldn't necessarily do this again for you, but for now. So 2 squared is 4. What happens when I square a square root? They cancel, right? Same thing here. This x to the 1 half really technically is a square root. So they're going to cancel and I just get x. So it looks like when I square that sucker, I'm going to get 8x, which is perfect. So plus 8x dx. Now I could do a u substitution, and that would be a valid thing to do, but as you get going in Calc 2, hopefully you're going to get to where you kind of see, I'm going to integrate 1 plus 8x to the 1 half. And I can kind of see that this is really, really close to integrating x to the 1 half. I just have that inside, where that inside has a derivative of 8. So I noticed that because of the chain rule, when I take its antiderivative, I'm just going to be off by 1/8. So I'm just going to go ahead and take the antiderivative of this with the power rule, bringing in that 1/8 to take care of the derivative of the inside. Okay, so the power rule tells me to add 1. So 1 half plus 1 is 3 halves. And then divide by 3 halves, that would be 2/3. I hope that makes sense to everyone. And then I have that 1/8. Now, could you do a u substitution? Absolutely do a u substitution. Change your bounds, right, in terms of u, and simplify. This is all my side work. This is stuff that I would, I want to say it because I'm your teacher. But if I were, you know, presenting this or something, I don't know why I'd be presenting this. This is the stuff I wouldn't show people, but I like to see your side work there. So let's see what we have. So I can simplify this a little bit. That's a 1, that's a 4. So I have 1/12. And then if I put in the 1, I get 9 to the 3/2 minus 1/12, right? I want to put in the 0 because I don't get 0. I get 1 to the 3/2. So let's see what this is going to be. I know you can figure this out, but just a reminder, again, sometimes it's hard to remember. What does this 2 do here? That square roots the 9, which would be 3, and then 3 to the 3rd is 27. So I have 27/12. I know a 3 comes out of those, but because I see here I'm going to just get minus 1/12, I'm actually not going to simplify this quite yet. We get 26/12, so you do not leave it like that, people. We can simplify that by dividing by 2. So my answer is 13/6, or about 2.17. Okay, so I hope that's pretty easy. I hope that kind of makes sense what we did there. Let's look at the graph of this and kind of see the length of the curve that we found. All right, so I'm just in Desmos here. So I'm going to do y equals 4 and then do SQRT for the square root of 2 divided by 3, x to the 3/2, and then minus 1. So there's the graph. Nothing too exciting, you know, to write home about, but we found that the length of that graph from 0 to 1, so this kind of chunk right here, that length is 13/6. And kind of a cool application of how we can actually find lengths of things that aren't just lines or circles or, you know, things we're used to finding the length of. Now we can actually find the length of things that are a little more curvy, which is pretty great. Right? All right, let's do another example, maybe one that's a little more interesting. Okay, so this one's going to be kind of, I wanted to do one like this for you because the algebra of this is kind of the hard part. It's not always easy to see, and I have a couple tricks for you on how to do this. I might do it a little bit differently than you might see other books do it, because I don't think it's always clear to see. You get a perfect square in here, and I don't know if it's always clear that that's true. I also wanted to say I'm not doing one where y is the independent variable and x is the dependent variable, but it's just going to be the same thing. You're just going to be integrating with respect to y as opposed to x. So let's kind of start off with this. Again, I know I need the derivative, so I'm going to take the derivative of this and I'm going to kind of mess with this to see kind of what happens. So if I take this derivative, that's 3x squared, right? The 12 just hangs out. You don't need to like do the quotient rule or anything because the 12 is just a constant. And then plus, if I think of this as x to the -1, its derivative is a negative x to the -2, right? So that -2 is, so that becomes a negative, and that guy goes on the bottom. And let's just simplify this a little bit. This is 1/4 x squared minus 1 over x squared. Okay, and now I know I need to square this. So I'm actually going to square it right now instead of doing this under the integrand, because this is a quite complicated integrand. I'm actually going to do a little bit of work outside here, and I'm going to figure out, can I simplify the inside of that square root at all? Just first by messing with this. So I'm going to have 1 plus, and then I need to square this guy, right? 1/4 x squared minus 1 over x squared squared. Now, again, what does it mean to square something? It means to multiply it times itself. So I'm going to go ahead, and because this doesn't look super easy to do, I'm actually going to write this out. This is like a classic problem for a length one that mathematicians just love because the algebra is really cool. What happens? Again, I don't just square each term because it's subtraction, and we know we cannot distribute exponents over addition or subtraction. So let's FOIL this sucker out. Always a good time to FOIL. So if I do the first 2, I get 1/16. I add exponents when I multiply like bases, so that's to the 4th. If I do the outside, look at what happens here. My x squareds cancel, right? And I'm just left with that 1/4. So I get minus 1/4. And then when you do the inside here, notice my x squareds cancel again because one of them's on the bottom. So just get another minus 1/4. And then finally, for last, if I multiply these two negatives become a positive, and then I multiply fractions just straight across. So that's 1 over x to the 4th, okay? So what do I get now? This is what, -1/2? 1/4 and 1/4 is 1/2, and I have that 1. So it looks like I get 1/16 x to the 4th, and I'm going to have plus 1/2, right, plus 1 over x to the 4th. I hope that makes sense. Now, this is tricky to see, but this actually is a perfect square. And one thing that you might do, I don't know about you, but I don't see that this is a perfect square. This actually factors into x squared over 4 plus 1 over x squared, quantity squared. If you don't see that, here's a hint that I want to give you. What you can do is you can actually find a common denominator for all of these. So what are our denominators, right? We have 16, we have 2, and we have x to the 4th. So our common denominator would be 16x to the 4th, right? That's something that each one of those terms is going to go in evenly. So let's look at this first term. I'm going to multiply this first term by x to the 4th over x to the 4th, right? Because that's what it's missing. This next term here, what would I need to multiply it by to get 16x to the 4th? 8x to the 4th over 8x to the 4th. And then this term here just needs 16 over 16. Again, this is if you don't see that this guy here is a perfect square, which I don't know about you, but I don't always see that. So I'm going to have this x to the 4th times x to the 4th. That's x to the 8th. We add exponents when we multiply like bases. Here I'm going to have in the numerator just an 8x to the 4th, right? And then over here I'm going to have 16. And all of this is all going to be over 16x to the 4th. And now why did I do that? Because remember, this whole thing's under the square root. So what you can see here is, well, when I square root this is, I'm going to be golden for the denominator, but notice the numerator here. Now that I think it's a little bit easier to see that this guy right here, actually, I can factor this into a perfect square. This factors into x to the 4th plus 4 times x to the 4th plus 4. And if you don't believe me, first of all, why don't you believe me? Second of all, go ahead and FOIL that out and you'll see you'll get x to the 8th plus 8x to the 4th plus 16. Whew, that's just algebra, people. That whole thing right there was just algebra. So now we're ready to find the length. So my length is going to be, we're going from 1, are we going from 1 to 4? Yep, 1 to 4. Okay, so now I'm going to go from 1 to 4. The square root of, right? And now I'm going to write it like this because I have it in a nice factored form here. So I would have x to the 4th plus 4 quantity squared all over 16x to the 4th. Again, if you look up how to do one like this in a different book or online, you'll see that they do it a little bit differently, but I know I'm adding a couple steps, but I think it's easier to see. Well, when I square root a squared, so you have to be a little careful when you square root a squared. Normally when you square root a squared, you have to take the absolute value of it because this squared right here doesn't make everything positive. But the good thing for us is anytime we take anything to the 4th, that's positive. So I actually don't need that absolute value right there. What's the square root of the denominator? Square root of 16 is 4. We have a lot of 4s here. Square root of x to the 4th is x squared dx. And now you guys, I'm going to be good to go. So I'm not quite ready yet, but I'm going to be able to divide this out. So if I take, again, I know sometimes I'm showing every step, and for some of you it might be like, yeah, why are you showing me that? But I have to be honest with you, where I see the biggest mistakes are with algebra. So this is all from just teaching experience. I'm showing you kind of where I see some of the misconceptions. So right here, I'm going to rewrite this a little bit, right? I can cancel 2 of these here. I'm going to rewrite that as 1/4 x squared. Here my 4's cancel and I have 1 over x squared, but I know I'm going to be taking the antiderivative. So I'm going to rewrite that as x to the -2 dx. Oh my goodness, we're almost done. And then this will be my shortest video yet. I'm very excited about that. So I have 1/4 times antiderivative of x squared is 1/3 x cubed. Antiderivative of x to the -2. Well, if I add 1 to it, I get -1 and divide by -1. Right, just gives me a negative, and this is from 1 to 4. And so now let's put in the 4. So I get 4 cubed, I believe, is 64. So I get 64 over 12 minus 1/4. Okay, I'm going to put in the 1, put parentheses, right, because I'm subtracting more than one term, minus 1/12 minus 1. Good, and now you can simplify all that. It looks like we get 63 twelfths minus, this becomes a plus, right? If we got rid of those 3/4. And then if I get a common denominator, multiply that. Oh, guys, I'm doing arithmetic in my head. This is usually not the best situation. If I subtract 9, I think that's 54/12, which if I divide by 2, right, is 27/6 maybe? No, I did something wrong here. Anyway, you get the picture. Hold on, let me figure this out really. Hi, I bet you saw it before I did. This is a plus. So if I add 9, I get 72/12. Sorry about that. You're probably yelling at the computer, which I don't blame you. So we get 6. That's the answer. So that was a pretty involved one, right? Again, if you look at some of the solutions in other books, what they'll do is they'll basically take this right here, and they'll just say, look at iMagick, this is basically 1/4 x squared plus x to the -2 squared. So you're welcome to, if you can see that, do it. I'm more power to you. If you don't see that, one trick, if you don't see that with the algebra, is to get a common denominator, because you have that x to the 4th in the bottom. All right, you guys, look those over. That was pretty fast for me. Go me. Let me know if you have any questions.